Hello everyone, this is Sabiroshan. Welcome to ArcGIS tutorial for beginners class 11. Today we will learn about some basic interpolation techniques and their uses. So at first click on 3D analysis toolbox. Here we see raster interpolation. So what is raster interpolation? Interpolation uses vector points with known values to estimate values at unknown location to create a raster surface covering an entire area. The interpolation result is typically a raster layer. It is important to find a suitable interpolation method to optimally estimate values for unknown location. There are some interpolation techniques in ArcGIS like IDW, Kriging, natural neighbor, Spline, topo to raster, trend, etc. So we'll discuss about IDW, Kriging, natural neighbor, and Spline today. So what is IDW? IDW means inverse distance weighting. It is a type of deterministic method for multivariate interpolation with a non-scattered set of points. The assigned values of unknown points are calculated with the weighted average of the values available at the points. The name given to this point type of method was motivated by the weighted average applied, since it restores to the inverse of the distance to each known point when assigning weight. Then next one is natural neighbor. So what is natural neighbor? Natural neighbor means inverse distance, natural neighbor inverse distance weighted. Natural neighbor interpolation has many positive features, can be used for both interpolation and exploration, and generally works well with clustered scatter points. Another weighted average method, the basic equation used in natural neighbor interpolation is identical to the one used in IDW interpolation. This method can efficiently handle large input point dataset when using the natural neighbor method. Local coordinates define the amount of influence any scatter point will have on output cells. The natural neighborhood method is a geometric estimation technique that uses natural neighbor regions generated around each point in the dataset. Now next one is Spline. Spline estimate value using a mathematical function that minimizes overall surface curvature, resulting in a smooth surface that passes exactly through the input points. Conceptually, it is analogous to bending a sheet of rubber to pass through known points while minimizing the total curvature of the surface. It feeds a mathematical function to be specified number of nearest input points while passing through the sample points. This method is best for gently varying surface such as elevation, water table height, or pollution concentration. And last one is Kriging. Kriging is a geostatistical interpolation technique that considers both the distance and the degree of variation between known data points when estimating value in unknown areas. A Kriged estimate is a weighted linear combination of the known sample values around the point to be estimated. Kriging is the most appropriate when you know there is a spatial correlated distance or directional bias in the data. It is often used in soil science and geology. So add the database and other shapefiles. Now we have Now we have 121 unions manganese measure, and another shape file have all the union names and other information. We need the manganese value with respect to the union names that are in shape file, so that why we'll apply join and relate. Right click on union or SQ, then click on join and relate option, then click join. Choose the base layer as UP name. Table to join database, and here field in table to base the join on also UP name. There we are. Down select keep only matching records and click on OK. So the unions that have manganese value given are being shown here. Now for interpolation, we have to divide the points into training and test sample. Training is the point that will be used for interpolation, and test are the point that will be used to calculate RMS error occurred by the specific interpolation technique. Now export the data to save it permanently. Give output directory. And rename it if you want, and then click on OK. Go to search option, search subset. Select the exported data in input features. Give the training and set test output directory. Okay. Here give size of training feature subset is 80%. You can also use 70/30 and click on OK here. Now here the test and train. Now start interpolating. Go to Arc toolbox. Then click on 3D analysis toolbox. Then click on raster interpolation, and then first one is IDW. Give all the values that needed in IDW. Please select train input point feature, and jet value is manganese. Then output give a directory. Give output cell size like 50. Then click on OK. That takes some time, so please wait for finishing. Okay, then apply Kriging in the same process. Click on OK and wait. In the same process, you can also apply a natural neighbor and spline. So now I want to work on these two files, Kriging and point IDW. Now time to the test the values. So to compare the values, go to search option and search for extract multivalues. Click on OK. Select the point features as the test and input raster as the IDW or Kriging. I select IDW. You can also select multiple raster input. Then click on OK. So if open attribute table test value, then these are now showing in one attribute table. Copy the whole attribute table and paste into the Excel. Open Excel file. And click and paste. Compute the RMS error of all four so RMS error formula is sum into sum 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 skew, then select the values. Sorry. Then select point IDW. Divided by count A then select another manganese and close the brackets and click on. Here is the RMS error is 0.15889. So you can also compare all force like Spline, IDW, Kriging and natural neighbor, and the lowest value of RMS error is the best for the interpolation. You can apply for practice. So now you can generate a contour lines from here too. So a contour line is a line drawn on a topographic map to indicate ground elevation or depression. A contour interval is the vertical distance or difference in the elevation between contour lines. Index contours are bold or thicker lines that appear at every feet contour. So get contour lines for such. Input raster like Spline or IDW or Kriging. I select IDW and give a directory contour. Give a contour interval like 0.2 and click on OK. So this is the contour line of your raster. Now zonal statistics. Another tool is zonal statistics. It calculates statistics on values of raster within the zones of another dataset. Search for zonal statistics. Input raster as Thana name, and Joel field district name. Input the output raster directory. Input and click on point IDW and then click on OK. So this is the zonal statistics shows. So this is for today. Thank you for watching. Bye.